All right, so this week we are going to do 3.5, and this lesson is going to focus on application problems. So we are going to be doing calculations within these problems as well as writing equations from these application problems. So first thing that it discusses is a 4-step procedure that we spoke about previously. Step 1, understand the problem. Step 2, devise a plan to solve the problem. Step 3, carry out the plan. And step 4 is to check your solution. And I just want to emphasize check your solution. A lot of people try to skip this step because you don't think it's necessary, but it is a very important step because it just verifies that your answer makes sense, right? If your answer makes no sense, then you know that you have a mistake somewhere along the way. So that's why it's really important just to check your solution, just to make sure that your answer does make sense and that you did in fact do it correctly. All right, so we have this first problem, and it says Jack and Diane are going to start saving for retirement. They deposit $1,000 in an account to start out, and then they plan to deposit $50 every month. So how long will it take until they have deposited $4,500? So first thing, step 1, understand this problem. So what information is provided in the statement that you're likely going to need? Well, the first thing that we were given is that they're going to deposit $1,000 to start. That's the initial amount of money. And just think that that amount of money is only happening one time. And then the other important information is that every month they're going to deposit $50, and they altogether need a total of $4,500. All right. So question 2, what is the problem asking us to find? It wants to know how many months will it take until they have $4,500. All right, so let's look at this plan that we have laid out, step 2. So how much is added every month? $50 is what's added every month. How much needs to be added to get to $4,500? Well, let's think. They're starting with $4,500, and I subtracted 1,000. Think about it. Why do you think I did 4,500 minus 1,000? Okay, what is the significance of doing that? Well, the 1,000 was the initial amount that they already had, right? So they needed 4,500 in total. They already had 1,000, which means that they only need 3,500 more, okay? So that's the first important thing that we need to figure out. And then if we need $3,500 and they're putting in $50 every month, okay, division is the operation that's going to figure out how many months they're gonna need. So 3,500 divided by $50 every month means 70. Okay, so 70 is the answer to our problem. So it's gonna take 70 months to get a total of 4,500. Now let's check our answer. If I did $50 times 70 months plus $1,000, that's gonna give us 4,500. So yes, it makes sense. Okay. Now, the way that we just did it here, this was the non-algebraic way of doing it, okay? This is using our common knowledge to figure out, well, what do we need to do? But there's another way we can do this. So if you look back, it's going back to step 2. Now we're going to bring variables in and try and write an equation to represent this situation. So we're going to let M represent the quantity in this problem that can change, and think about what is M going to be representing. It's going to be the number of months. So they're going to be earning $50, right? Depositing $50 every month. So 50M means $50 per month. And then to write an equation, well, $50 per month plus the initial $1,000 that we have will equal the $4,500 in total. And then I went ahead and solved this problem. First, I subtracted $1,000 from both sides, and then 3,500 is my result, and I divided that by 50, because to undo multiplication we divide, and that gives us 70. And you can notice that we get the exact same answer, but this is the algebraic approach to solving the problem. So if a problem asks you to write out an equation, you have to write out an equation. The other way is a perfectly great way of doing it, but it just is not the algebraic approach. All right. So question number 8. Generalize this problem to develop a framework that would allow someone to input any starting amount and any monthly amount and be able to quickly determine how long it would take to reach a specific savings goal. So what we're looking at is we're looking to come up with an equation that will always work for this type of problem, okay? So what I wrote is the total amount will always be equal to the amount per month times the number of months plus the starting amount or the initial deposit. Okay, and then I just put random variables. You can come up with any variables you want. Just make sure you identify what they are. So T stands for total is equal to A, amount every month, times M, number of months, plus S, starting money. Okay, so this will be an equation that you can always use when you're given this type of situation. And then I did the, did you get it? Just so you can see another example of problems. And that takes us to the end of the classwork. So the group work section is going to have a couple more application problems for you to try on your own. Please try them, do the best that you can. Once you feel like you've done all that you can, check out the next video on 3-5 group work to check your answers. And again, let me know if you have any questions. The 3-5 homework is going to be due on Wednesday at 9:30 a.m. So please make sure you get that done and also seek out and let me know if you have any questions.